Our world runs on data. We generate 2.5 quintillion bytes of data every day. Sending one selfie to a friend on Snapchat requires 1 megabyte of storage. Posting a story on Instagram, much more. But even as the data generation process is accelerating at a breakneck pace, the same cannot be said about the data storage infrastructure. Every year we pay hundreds of dollars to buy cloud storage, and every year we run out of additional space. How then are hundreds of thousands of NFTs, from CryptoPunks to Pixelmons, stored on every single network computer on the Ethereum blockchain? Well, the answer is they are not. At least not always. Welcome to Leapfrog, a channel dedicated to making animated explainer videos, simplifying crypto and decentralized finance. If you're new here, be sure to subscribe and don't miss our future videos explaining the magic behind the scenes of crypto. Before we go into the storage constraints, first let's understand how NFTs work. NFTs are unique digital images that cannot be replicated. If I owned the original Mona Lisa in real life, I would have the only Mona Lisa in the world. Everyone else's copy would be a fake. Similarly, if Mona Lisa were a digital image created and published on a blockchain, whoever bought it would be the only one who owns the real Mona Lisa digital image. Everything else would be a fake, a copy of the original digital image. But Leapfrog, the images I click are uploaded on my own Instagram account. I own all of them. No, my friend, you don't. The images on your social media or the ones on your Google Drive are stored in the data warehouses of these tech giants like Meta and Google. Yes, you have access to that storage, but you don't exactly own them. Meta and Google own those pictures and they could remove them at their will. If they do so, all your digital memories will disappear from the face of the earth without your consent. This cannot be done if your images are NFTs. That's what makes every NFT unique, or in technical terms, non-fungible. This brings us back to the question of storage. If these images are not stored on the blockchain, where are they really stored? The answer to that is hidden in the technical definition of NFTs. An NFT is a unique digital identifier recorded on the blockchain. Let's break this down with an analogy. Imagine there's an art museum. Artists can publish new art there, and the viewers can go in and purchase the art and trade it with other museum visitors. The museum keeps track of all the metadetails related to each piece of art in a record book. The original artist, the trade history of the piece, who bought and sold the art, and its current address, where the art is located right now. This location could be within or outside of the museum. Now, extrapolating this analogy to our discussion, the blockchain is like the art museum. NFTs are a combination of two parts: the actual art, or the media file, and its metadata, or the record book. When an NFT is purchased, a new record is created in the record book, or the smart contract. This smart contract contains all the metadata for that NFT. It does not contain the actual art itself, but points to the location where it is currently stored, within or outside of the blockchain. Yes, you heard that right. The actual art is more often than not stored completely away from the blockchain. For what it's worth, it could be simply stored in Amazon's AWS servers or a Google Drive somewhere. Because the media files are so large, storing them on every computer on the blockchain would make the chain slow and inefficient. But as we already discussed earlier, this presents a huge problem. The Amazon and Google servers are still centralized. What happens if they shut down or choose to remove some of the media files? Enter IPFS, or Interplanetary File System. IPFS is a distributed file storage protocol allowing a network of computers to store any arbitrary information in a robust and immutable way. If you've used BitTorrent, IPFS approximately works like that. But let's use a simpler and more precise analogy: a jigsaw puzzle. IPFS breaks down each file into multiple fragments like the pieces of a jigsaw puzzle. Then it stores these pieces on multiple network computers across the globe. When someone requests for the file, IPFS brings together these individual fragments to compose the entire file. Since each piece is unique, it ensures that no one is able to alter any data. In other words, IPFS comes with built-in security. In technical terms, the data stored via IPFS is immutable. Okay, but what happens if one of the nodes containing a piece shuts down? That's a good question, and the solution that IPFS came up with is even better. When the jigsaw puzzle pieces are being sent to the node computers, many nodes click a picture of the final assembled file and keep it with them. If one of the nodes shuts down and a jigsaw piece is missing, these other nodes use that clicked picture to recreate the missing piece. This way, the file remains immutable even if some nodes shut down. Finally, coming back to our original topic of discussion, IPFS is how the media part of NFTs is stored to keep the storage costs low while keeping the file secure from a single point of failure. As a closing note, this does not mean NFTs are never stored on-chain. In fact, recently, the actual contents of the NFT have been stored on-chain thanks to both base64 encoding, which is a binary-to-text encoding scheme, and SVG files, which is a file type that achieves superior compression of images by drawing them using math rather than pixel by pixel. While IPFS has the lead currency, it remains to be seen if it stays the dominant way to store NFTs over the coming years. We hope you enjoyed watching this video as much as we enjoyed making it. Make sure to hit the like button and subscribe to the channel. We make these videos every week, and your support keeps us going.